Imagine looking up at the sky on a clear night and seeing the vast blanket of stars we usually admire, but with one difference. Instead of seeing that sky full of life, light, and distant galaxies, you are faced with an absolute void, a deep and infinite darkness where there is no longer the sparkle of stars nor light to guide the way. There is no more movement, no more brightness, only silence and solitude. The universe as we know it has come to an end. The death of the universe will not be instantaneous, but rather a gradual process that will unfold over billions of years, an event so vast it is almost impossible to fully comprehend. However, the future of the cosmos is not uncertain. It is predictable based on the laws of physics that govern space and time. What we know, and what astronomers and physicists have observed over the past decades, is that the universe is expanding at an accelerated rate. Since the theory of cosmic expansion was confirmed by Edwin Hubble in the 1920s, we have known that the universe is growing, with galaxies moving away from one another. However, what was discovered in 1998 was far more disturbing. The universe is not only expanding, but its expansion is accelerating. This phenomenon is driven by a force we still do not fully understand: dark energy. Scientists estimate that dark energy makes up about 68% of the entire universe, but despite its vast presence, no one knows exactly what it is. What we do know is that it exerts a repulsive pressure, causing space-time to expand at an ever-increasing rate. When the universe was formed about 13.8 billion years ago, expansion was happening at a steady pace. However, since dark energy came into play, the expansion has accelerated, meaning that galaxies are moving away from one another faster each day. According to observations from the Hubble Space Telescope and Type Ia supernova expeditions, the rate of expansion of the universe, known as the Hubble constant, is estimated to be around 70 km/s per megaparsec. This indicates that the distance between galaxies is increasing at an accelerated pace. To grasp the scale of this, imagine that billions of years from now, the most distant galaxies will be so far away that they will no longer be visible to the naked eye. The light from those galaxies will never again reach Earth, creating a universe that becomes increasingly dark and isolated. Dark energy, the driving force of accelerated expansion. Dark energy is one of the greatest mysteries in modern physics. It is estimated to make up about 68% of the entire universe, but despite its vast presence, no one knows exactly what it is. What we do know is that it exerts a repulsive pressure, causing space-time to expand at an ever-increasing rate. When the universe was formed about 13.8 billion years ago, expansion occurred at a constant rate. However, since dark energy began to dominate, expansion has accelerated, meaning galaxies are drifting apart faster and faster. How do scientists know this? The study conducted by Saul Perlmutter, Adam Rees, and Brian P. Schmidt, which earned them the 2011 Nobel Prize in Physics, used Type Ia supernovae as standard candles to measure cosmic distances. These supernovae are stellar explosions that always have the same peak luminosity, allowing astronomers to calculate galactic distances with great precision. The discovery that these supernovae were farther away than expected led scientists to conclude that the universe was expanding at an accelerating rate. This process has profound implications. Dark energy not only accelerates the expansion of the universe, but it also suggests that the future of the cosmos will be marked by a continuous separation of galaxies, leading the universe to become increasingly isolated and dark. In the distant future, the acceleration of expansion will cause galaxies to move apart faster than the speed of light, and their light will never again reach Earth. The end of stars and the death of galaxies. The fate of stars is one of the clearest signs that the universe is dying. Star formation occurs in molecular clouds, massive regions of gas and dust that collapse under gravity to form new stars. However, this stellar formation is declining significantly. According to a 2016 study published in the journal Science, the rate of star formation in galaxies has dropped from about 15 stars per year to less than 1 star per year in recent decades. Galaxies like the Milky Way, which still form some stars, are gradually running out of the fuel needed to create new ones. The process of stellar death also involves a series of transformations. When a massive star reaches the end of its life, it can explode as a supernova, releasing enormous amounts of energy and scattering its atoms throughout the cosmos. These explosions are one of the primary sources of heavy elements, such as iron, that spread across galaxies. However, even these supernovae cannot prevent the inevitable. Without new stars, the universe will begin to lose its vitality. Low-mass stars, like our Sun, go through a much calmer process. They expand into a phase called a red giant, and eventually become white dwarfs, cold, inactive stars. The Sun, for example, is currently in its main sequence phase, where it converts hydrogen into helium through nuclear fusion. However, once its hydrogen fuel runs out, the Sun will begin to expand, engulfing the nearest planets, such as Mercury and Venus, and will become a red giant. About 5 billion years from now, it will lose a large portion of its mass and stabilize as a white dwarf, a dying star that over time will cool down and fade away. Nuclear fusion will cease, and the Sun will become a cold ball of carbon. When stars die, the light of the universe begins to fade. This marks the end of stellar creation. Galaxies will become inactive structures composed only of old stars that over time will extinguish. Eventually, galaxies like the Milky Way will lose their vitality. As confirmed by astronomers from the Arecibo Observatory and the Hubble Space Telescope, galaxies are moving away from one another due to the acceleration of cosmic expansion. Billions of years from now, nearby galaxies like Andromeda will have drifted so far apart that in the future, galaxies will become isolated islands, far away from each other. The heat death of the universe, the final fade out. As time passes, matter in the universe will become increasingly dispersed. The heat death is a fundamental concept that describes the ultimate end of the universe. Entropy, the measure of disorder or randomness in a system, will grow until energy is spread so evenly that the universe will become a completely lifeless place, without stars to produce heat and light, and with all energy diffusing randomly. The universe will enter a state of thermal equilibrium where nothing else can happen. This will be the final stage of the cosmos, an absolute frozen void. The concept of heat death is not new. Scientists such as Maxwell and Boltzmann in the 19th century had already proposed that the universe would end in a state of maximum entropy, where all energy would be evenly distributed, and no form of life or motion would be possible anymore. The dissipation of energy will be so intense that there will be no more heat, no more light, and no more movement. It will be the eternal silence of the universe. As the cosmos approaches this thermal death, dark matter, which makes up about 27% of the universe, will continue its silent existence. Although dark matter does not interact directly with light or ordinary matter in conventional ways, it plays an essential role in forming the structures of the cosmos. Dark matter helps keep galaxies bound together, preventing the expansion forces of the universe from tearing them apart. However, as dark energy accelerates the expansion and gravity loses its power, galaxies will eventually disperse, and dark matter will also thin out. This cosmic disintegration will culminate in what we call the universal gravitational collapse. Over time, gravity will lose its strength and its ability to keep the structures of the universe intact. Galaxies will disintegrate, stars will go dark, and the universe will become a vast, silent space filled with faint radiation, scattered particles, and entropy. There will be no more stars, no more light, and the cosmos will be a total void. This process of cosmic death will be slow and gradual, taking billions of years before the universe exhales its final breath. But one thing is certain: the universe is dying. It is not a question of if, but when. At some point, the cosmos will become a cold and desolate space where the glow of stars and the vital energy of galaxies will vanish forever. And while we are still at the height of our existence, it is crucial to reflect on what we can do to understand and preserve the best of what the universe has to offer. If you are as fascinated as we are by the idea of learning more about the end of the cosmos, make sure to subscribe to our channel and follow more videos about the latest scientific discoveries. Comment below your thoughts on the future of the universe and what you think about all of this. What else would you like to learn about the cosmos and the fate of the universe? And don't forget to turn on the notification bell so you don't miss any new content.